In this video, we are going to learn how to import and visualize videos in MATLAB. Videos can be brought into MATLAB through video files or from cameras. So specifically, we will talk about how to import and play a video file, configure a camera for image acquisition, and acquire images from a camera. This training is useful for all AUVSI teams since it covers the general topic about bringing data into MATLAB for image processing and computer vision tasks. We would like to thank the Cedarville University RoboBot team for providing us with videos and image files for us to use in this training. For example, we are going to take this video where a robot boat is navigating a field of colored buoys. The task in this example is to import and play this video file in MATLAB. Before we begin, a quick note here that we are going to be using several number of what are called system objects throughout this training. System objects are one kind of MATLAB objects that are specifically good at handling streaming data. Unlike any other object, system objects also have properties that define the characteristics of the object and methods which are operations or functions that can be performed with those objects. Examples for some system objects in MATLAB are video file reader, which can be used to read video files, video device, which can be used to connect to cameras and other video devices, blob analysis, which can be used to perform blob analysis algorithm on existing images, etc. The advantages of using system objects are that they are very efficient when processing streaming data, hence faster execution is possible. They support C code generation through MATLAB Coder product, and they facilitate easier portability of functionality between MATLAB and Simulink. Let's begin by importing a video file. To do this, let's switch to MATLAB. The first step in importing video frames, images, and audio samples from a video file is to set up a video file reader system object. To do this, let's use a MATLAB variable. So in this case, I'm going to call it vidReader equals vision dot video file reader, and then provide the name of the video file, in this case buoyrun.avi, which you can see here, and then end this with a semicolon and then hit enter. So here we have created a video file reader system object. This object defines the properties of the imported video file. You can get a list of all possible properties associated with the video file reader system object or any other system object using the properties function. So I can say properties on my vidReader, which is the system object, and then hit enter to see all the properties associated with the system object. For the video file reader, we can see properties such as file name, video output data type, etc. To set the value of a property, you can use the dot operator syntax. So here I can say vidReader dot, and then hit the tab key on your keyboard to get a list of all properties and methods associated with this object. So in this case, we need the video output data type. So select that equals, and then begin our output data type string using our single quote, and then hit tab again to get a list of valid values for this property. So in this case, I can set this to any of these values. Let's suppose we would like to set this to double. So select that and then end this with a semicolon. The video file reader system object also has methods associated with it which can be applied to the object. Methods associated with the system object can be listed using the methods function on the system object. So in this case, it's vidReader, and then hit enter to take a look at all the methods associated with this particular system object. Step is the key method for all system objects which helps you process the input data and handle object states. For the video file reader, use step to sequentially read video frames and/or audio frames from the input. Every call to step returns the next video frame. Let's look at an example. So in this case, the output video frame vid frame, which is a MATLAB variable, equals step on our video reader, and then hit enter. So here you can see vid frame is an array of size m by n by 3, which is an RGB array. So each video frame here is actually a static image. Now we can use IMShow on the static image, in this case it's vid frame, to visualize this image. So here is the first frame from our sample video. Let's go back to the MATLAB command prompt here. Once we are done using the system objects, it is good practice to release all the system resources associated with the system objects, such as memory and file handles, at the end of your program. This can be done using release on the system object, so in this case it's vidReader. Release also allows all properties and input characteristics of the object to be changed, which is otherwise locked once the system object is in use, particularly when the step on the system object is used. Our next task is to sequentially acquire each frame in the video file. To do this, let's copy some of these commands from the command history here. So I'm going to copy the video file reader creation, setting of the output data type, step, IMShow, and release. Right-click on all these commands and create a new script using the Create Script option here. Algorithms involving system objects usually fall into 3 sections. So the first section will be setup. The second section will be looping. And the last section will be cleanup. Let's go ahead and save the script as import buoy video, and then save this file. Note in the setup section here that you can set the properties of a system object by using name value pair syntax during the object creation itself instead of using the dot syntax here. For example, here I can combine these two commands into a single command. So here I can delete all these texts here. buoyrun.avi, followed by the property name within single quotes, followed by the value of that property, so in this case it's double, and then end this here. Note that this is the preferred method for setting properties when deploying or generating code for system objects. Now let's go ahead and implement this loop here. To do this, let's create a while loop. So I can say while. We need a termination condition here for the loop. In this case, we need to determine whether the end of file is reached or not. We can use isDone on our system object video reader to figure out if the end of file is reached. Note that we need to know if the end of file is not reached, so let's go ahead and use the not operator in MATLAB, which is the tilde operator. Inside this loop, we are going to execute these two commands. So let's indent them appropriately and then end this loop. Before running the script, I'm going to use my shortcut here to clear all my workspace variables, my command prompt, and close all existing figures. And then let's go ahead and run the script. Note that the frames don't seem to update in real time. This is because MATLAB is processing the frames as fast as it can. If you time this piece of code using tick and tock commands, you can observe that MATLAB takes almost 30 seconds to go through the loop. Our original video is 45 seconds long, and this means just to read a particular frame, MATLAB is spending the bulk amount of time. Let's go back to the script here. Curiously, this is because we are using the imShow function to show constantly updating images or a video file in this case. This function is particularly suited for static images. For constantly updating images or videos, we recommend the use of a deployable video player system object. So let's go ahead and create the system object in our setup section here. So I can say vid player equals vision dot, and then I can hit tab to bring up the list of system objects here. So I can say deployable video player. And then to use this deployable video player, we can use step on this system object. So inside this loop here, let's go ahead and delete the imShow function here. And instead, we can say step on my video player, and then update this video player using the video frame that we just acquired here. Also remember that the deployable video player is a system object as well. So let's go ahead and release this object once we are done with it. Let's go ahead and run the script. Notice the improved performance here. Note also that in the loop that we just implemented, in addition to just playing a video file, we could be doing other image processing and computer vision tasks. We'll take a look at some of these tasks in later videos. Let's go back to the presentation to do a small recap. We started with the video file reader system object. We saw how to query for properties and methods of a given system object. We also discussed two different methods to instantiate object properties through the dot operator syntax or during object creation using name-value pair syntax. Note that only the name-value pair syntax is supported for deployment and code generation. Then we used step on the system object to acquire the next frame of the video file. Then we implemented a loop with imShow function to consecutively acquire and visualize the video frames. Here we discussed about how imShow is suited for static images, and for constantly updating images or videos, deployable video player is recommended. So we used the deployable video player and saw how we can get a better performance for videos. We also noted that once you read in a video frame, you could do other image processing and computer vision tasks inside the same loop here in addition to playing a video. We will discuss some of these more common tasks in other videos. The next step is to learn how to acquire image from a camera so that we can do live processing. Let's switch to MATLAB here. I'm going to clean up my workspace. For any cameras that use the Windows Video, Macintosh Video, or Linux Video adapters, install the hardware support package called OS Generic Video Interface. To access the installer, go to the MATLAB Home tab, and then under the Resources section, click on Add-ons, and then click on Get Hardware Support Packages. Here, select Install from Internet to install the selected support package and other third-party software associated with the support package from the Internet, and then click on Next. On the Select Support Package to Install screen, you will see all of the adapters listed if you have the Image Acquisition Toolbox. Let's scroll down here and select OS Generic Video Interface as the support package to install. The correct files will be installed depending on your operating system, so click on Next. If you're prompted to log into your MathWorks account, click on Login to continue. Provide the necessary credentials here. Read through the MathWorks Auxiliary Software License Agreement. Click on I accept, and then click on Next. The support package installer confirms that you're installing the support package you selected and lists the installation location. Confirm your selection and click Install. After the installation, you will see a confirmation message. Click on Finish to close the support package installer. Now that we have installed the support package, let's take a look at the list of available hardware from which we can access the images. To do this, use the iMac hardware info command. Here we see that the installed adapter is WinVideo, so any supported camera for WinVideo can be used to acquire images. The first step in acquiring image frames is to set up a video device system object. We can do this by using a MATLAB variable first, so myCam equals iMac.videoDevice, and then provide the name of the adapter. So in this case, I'm going to say WinVideo. This object, myCam, which is a video device object, defines the properties of the video device. Similar to the video file reader object, to set value to a property, you can either use the nameValuePair method while creating the object or use the dot operator syntax. Let's use the dot operator syntax here. So I can say myCam dot and then hit tab. So let's suppose we would like to set the property video format equals open single quote to begin the value for the video format and then hit tab to retrieve list of valid values. So in this case, I'm going to choose 640 by 480 and then hit enter here. The myCam object also has methods associated with it, which can be applied to the object. Recall that you can use the methods function on the object to retrieve a list of available methods for that particular object. In this case, I'm going to use the preview on my object myCam to take a look at the current feed from the webcam. So here I have a Lego robot that is standing on its tail here. Let's close this preview here. We can sequentially read video frames and our audio frames using step on our myCam video device object, similar to the video file reader object. So I can say cam frame equals step on myCam. So here you can see cam frame is also an array of size m by n by 3, which is a RGB array. And I can take a look at this by using imShow on my array, which is cam frame. So this was the acquired image. Let's go back to MATLAB here. Now to sequentially acquire these video frames, we can implement a loop and display the acquired video using a deployable video player object. Let's take a look at an example script to see how we can do this. So I'm going to open up acquireimages.m and scroll down here. So in this section, we are creating a deployable video player object, and then using a for loop, we are reading 200 frames from the camera and then displaying it on the video player. Let's run this section here. So you see this is a live stream of our robot here. So those were 200 frames that were just acquired. Remember that video device is also a system object. So in our cleanup section here, we release the myCam object here. So let's go ahead and run this section as well. Let's go back to the presentation and do a recap. We started by installing the OS generic video interface support package through the add-ons menu in MATLAB. After completing the installation, we executed the iMac hardware info command to take a look at the existing adapters to connect to. Then we use step on the video device object to acquire the current frame. We also checked the preview function to take a look at the current live stream of the camera. We also looked at an example to acquire the images in a loop. In this case, we used a for loop. In summary, we talked about how to import, play the video file frame by frame, and also acquire the video from a camera. This concludes this video.